How about you pause and read the question before we continue? So what Ali thinks is that no matter what value I take for n and I substitute it in this expression, I will get a prime number. So Ali believes that no matter what whole number I take, let me take n equals 1. My E will be 1 squared plus 1 plus 5 is 7. So it is prime. Let me take n equals 2. E equals 2 squared plus 2 plus 5. 4 plus 2, 6 plus 5, 11. It is prime. Let me take n equals 3. E equals 3 squared plus 3 plus 5. 9 plus 3, 12 plus 3, 5, 17 is prime. So the question is Ali correct that for any whole number, if I keep going, n equals 4, 5, and so on, all of them will be prime? Now I can't keep going, so I can take a check with my calculator. Calculator is actually very useful, because if I give it this expression, it can return me a table of values showing me the values of the expression L for E for many values of n. I can choose for how many. Now, if it happens that I notice that pretty much all of them are prime numbers, if I try 10, 15, 20, and so on, then it's still not enough to justify that Ali is correct. So I would need a very general proof. But it's worth trying, because if I find a single number, n, which after substituting the expression E will not give me prime, it means that Ali is not correct. Actually, I could continue by hand, and I will see, just because I tried before, that for E equals 4, I get 4 squared plus 4 plus 5. So 16 plus 4, 20 plus 5, 25. Not prime. So Ali is not correct. I can show you, however, how using my calculator, I can make my calculation simpler. So let's look into the use of the best use of a calculator. Okay, so here we go. F of x is of value E. That's how my calculator remembers it or recognizes it. It can just cope with x. So instead of n, I'm going to type x. And now it tells me what do I want x to be. I want it to start with 1, and that maybe let's go until 15 or 20, until 20. Step 1. Meaning that when x equals 1, the value is 7. When x equals to the value, it's 11, see, 17. And look how for 4, it's a first number that is not prime, it's 25. From 5, it's still not prime. For 6, it seems to be prime, for 7 prime, but it doesn't really matter, because for x equals 4, I see that the expression is 25, so it's not a prime. Therefore, it's not true that E will be prime for any whole number, because for some it is not. In order to score full marks, it's not necessary just to say that Ali is not correct, but to give a reason why it's not correct. And the reason is because, for example, for n equals 4, E is not prime. The reason could be as well for n equals 5, F is not prime. You can turn your page to see a similar problem. Okay, here is a question for you. Use your calculator in a smart way, as we've seen on the previous page, to justify why the expression n squared plus n plus 1 is not prime for all positive integer values of n.